The future is about to get extraordinary. From advanced AI and quantum computing to fusion-powered spacecraft, next-gen robotics, and sustainable energy breakthroughs, the world of 2025 to 2030 promises revolutionary change. In this video, we explore 20 cutting-edge technologies set to transform industries, daily life, and how we interact with the planet. Witness the innovations and visionary concepts that could redefine transportation, healthcare, communication, and entertainment. Get ready to see what's coming next, and how these breakthroughs will shape our lives in the decade ahead. BrainBridge. BrainBridge introduces a highly advanced concept that blends robotics, artificial intelligence, and molecular imaging into a unified system designed for complete head or face transplantation. The idea centers on autonomous surgical robots equipped with ultra-precise tools capable of handling delicate neural and vascular structures with microscopic accuracy. A key element of the concept is the BrainBridge headband, a brain-computer interface intended to allow patient communication throughout recovery. The system also includes the use of PEG-based neural adhesives to support the reconnection of severed neurons. BrainBridge is presented as a potential solution for individuals facing severe paralysis, terminal illness, or progressive neurological conditions, aiming to preserve memory, identity, and cognitive function. By combining intelligent robotics with advanced biomedical engineering, BrainBridge showcases a futuristic direction in medical innovation, highlighting how technology could reshape complex surgical procedures and expand possibilities for life-preserving interventions. KRONOS MMR. The KRONOS MMR is an advanced micro-modular reactor concept developed by Nano-Nuclear Energy, designed to deliver dependable, high-efficiency power through a compact and highly engineered system. It uses triso particle fuel, a graphite moderator, and helium cooling to maintain stable high-temperature operation. A secondary molten salt loop allows the reactor to store heat and shift energy between electricity generation, industrial processes, and steam production, giving it impressive flexibility for different applications. The project includes a development site at the University of Illinois Urbana-Champaign, where early groundwork and infrastructure planning have begun in partnership with ECOM. KRONOS MMR also follows a structured licensing pathway with the U.S. Nuclear Regulatory Commission, supported by approved fuel qualification methodologies and a growing engineering team. With its modular design and forward-focused engineering, KRONOS MMR highlights a modern approach to clean, resilient, and scalable nuclear energy. Microfluidic cooling. Microfluidic cooling is emerging as a critical technology for high-performance computing, enabling precise heat management directly within microchips. By routing liquid coolant through microscopic channels etched into the silicon, this approach removes heat more efficiently than traditional cold plate or external loop systems. Microsoft has demonstrated microfluidic designs that reduce GPU temperature rises by up to 65% and achieve 3 times better heat dissipation, using AI-guided optimization inspired by natural structures like leaf veins. Swiss startup Corintis is advancing similar in-chip cooling systems for dense processors and AI accelerators. Research studies including GlacierWare and Cool3D show that topology optimization and 3D stacked architectures can further enhance cooling efficiency and chip reliability. As processors grow more powerful and compact, microfluidic cooling provides a scalable, energy-efficient solution, enabling faster computation, higher performance, and longer chip lifespan. It represents a fundamental step in the evolution of computing hardware. Cognify facility. Cognify is a groundbreaking concept that reimagines criminal rehabilitation using advanced AI and neuroscience. Instead of traditional incarceration, offenders could undergo a neural implant procedure that embeds synthetic memories directly into the brain. These AI-generated experiences allow inmates to relive their crimes from the victim's perspective, inducing empathy, guilt, and remorse. High-resolution brain scans target regions such as the hippocampus, prefrontal cortex, amygdala, and anterior cingulate to deliver memories safely and effectively. While the experiences feel like years to the inmate, they unfold in mere minutes of real time, monitored by an adaptive AI system that optimizes therapy for each individual. Cognify aims to reduce incarceration lengths, lower recidivism, and redirect criminal justice resources into social programs. By merging neuroscience, artificial intelligence, and ethical debate, Cognify presents a provocative vision of justice where rehabilitation and human understanding take precedence over punishment. Peugeot Polygon concept. The Peugeot Polygon concept is a bold preview of the brand's next-generation compact electric vehicles, blending futuristic design, advanced technology, and sustainability. Measuring under 4 meters, it is optimized for urban mobility. The car introduces a hypersquare steering controller combined with steer-by-wire technology, offering highly precise, vibration-free handling and variable steering ratios for agile city driving. Its cockpit features a 24 by 74 centimeters micro-LED display projected directly onto the windshield, integrating Peugeot's immersive iCockpit philosophy. Gull-wing doors, 3D printed seats, and modular, swappable components enhance personalization and sustainability. Wheels made from recycled plastic, fewer overall parts, and recyclable materials highlight eco-conscious engineering. Peugeot also showcased the Polygon digitally in Fortnite, signaling a shift toward virtual-first product engagement. With these innovations, the Polygon concept demonstrates how future urban EVs could merge compact design, high-tech driving interfaces, sustainable materials, and interactive digital experiences, shaping the next era of electric mobility. General Fusion's MTF. General Fusion, a Canadian company, is developing a practical approach to fusion energy using magnetized target fusion. Their system combines magnetic and inertial confinement principles to achieve fusion conditions more efficiently. A compact toroid plasma is generated and injected into a cavity filled with liquid metal, such as a lead-lithium alloy. Around the cavity, high-speed pistons compress the liquid metal symmetrically, heating the plasma to over 100 million degrees Celsius. Unlike traditional fusion systems, MTF uses simple copper electromagnets, reducing complexity and cost. The liquid metal wall confines plasma, handles neutron flux, and breeds tritium fuel. General Fusion's demonstration machine, LM26, is being built to validate this approach, supported by proprietary, peer-reviewed simulation software. Partnerships with companies like Kyoto Fusioneering help scale tritium handling and power conversion. If successful, MTF could provide a commercially viable, clean fusion energy solution for the 2030s. Willow Quantum Chip. Google Quantum AI's Willow is a pioneering quantum processor with 105 superconducting transmon qubits arranged in a 2D grid. It supports real-time quantum error correction, operating below threshold, which means error correction outpaces error generation as the system scales. In random circuit sampling tests, Willow completed complex computations in under 5 minutes, significantly faster than classical supercomputers. Its qubits maintain coherence for nearly 100 microseconds, about 5 times longer than Google's Sycamore chip. Using the quantum echoes algorithm, Willow performed nuclear magnetic resonance modeling 13,000 times faster than top classical systems. Fabricated at Google's Santa Barbara Quantum Foundry, it features advanced lithography, 3D interconnects, and optimized qubit layouts. While it cannot yet break modern encryption, which requires millions of error-corrected qubits, Willow represents a major step towards scalable, fault-tolerant quantum computing, bridging the gap to practical quantum applications and marking a new era in quantum technology. Agile ONE. Agile Robots SE has introduced Agile ONE, a humanoid robot designed for industrial automation, marking a significant step in the physical AI era. Agile ONE operates alongside humans and machines in manufacturing, logistics, and material handling, combining advanced perception, dexterous manipulation, and mobility. Equipped with cameras, LiDAR, speech recognition, and proximity sensors, it can sense and respond dynamically to its surroundings, while expressive eyes and a chest-mounted display enable intuitive human interaction. Its hands feature 21 joints each, with force and tactile sensors, allowing precise handling of delicate and heavy tasks. Standing 174 centimeters tall and weighing around 69 kilograms, Agile ONE can walk at up to 2 meters per second, delivering natural human-like movement. Built on a layered AI architecture, it learns from real workflows, simulations, and human demonstrations. Integrated into Agile Robots' ecosystem via Agile Core, it connects, collaborates, and learns across industrial workflows, representing the future of adaptable, intelligent factory automation. TAE Norm Fusion Machine. TAE Technologies' Norm Fusion Machine represents a major leap in nuclear fusion technology, built on the company's proprietary beam-driven field-reversed configuration design. Unlike previous models, Norm forms plasma using only neutral beam injection, removing the need for complex collision-based formation hardware. This simplification reduces system complexity and costs by up to 50%, while the FRC topology enables self-generated magnetic confinement, requiring fewer external magnets and a simpler reactor structure. Peer-reviewed results show that Norm can form, heat, and stabilize fusion-grade plasma at the device's core, demonstrating efficient, controlled energy conditions. With upgrades underway to reach 100 million degrees Celsius, NORM is moving closer to commercial viability. By bypassing intermediate machines, it accelerates TAE's path toward its first hydrogen-boron fusion power plant, Da Vinci. NORM's streamlined design, efficiency, and stability mark it as a pivotal platform in the transition toward practical, carbon-free, large-scale fusion energy for the near future. Proxima Fusion. Proxima Fusion is pioneering the next generation of clean energy with its advanced quasi-isodynamic stellarators, offering continuous plasma stability for commercial fusion power. Emerging from the Max Planck Institute for Plasma Physics, Proxima leverages decades of stellarator research, including insights from the Wendelstein 7X experiment. Their flagship reactor concept, Stellaris, integrates high-performance simulation, AI-driven design, and high-temperature superconducting magnets to optimize plasma confinement, thermal management, and overall plant efficiency. Proxima is developing a stellarator model coil to validate their approach in hardware, combining physics, engineering, and maintainability into a scalable fusion platform. Collaborating with leading institutions across Europe, their multidisciplinary team of physicists and engineers focuses on translating complex theoretical models into practical, grid-connected fusion technology. By emphasizing robust design, advanced simulations, and cutting-edge magnet technology, Proxima Fusion aims to accelerate the path toward reliable, commercially viable fusion energy, promising a future of abundant carbon-free power. NTT Data Technology. NTT Data is a global IT services and consulting company that is part of the larger NTT Group, operating in more than 50 countries. The company helps organizations with digital transformation, modernization, and innovation across industries. Its services include consulting, enterprise applications, data and AI, cloud and infrastructure, cybersecurity, business process services, and sustainability solutions. NTT Data invests heavily in research and development, operating innovation centers worldwide, and collaborating with academic institutions and startups to explore emerging technologies. Their Technology Foresight initiative studies future trends to align business solutions with societal needs. The company's global delivery model combines local expertise with international scale, supporting industries such as healthcare, finance, and manufacturing. With a strong focus on innovation, sustainability, and secure digital operations, NTT Data plays a key role in helping enterprises become more connected, intelligent, and adaptive in the evolving digital landscape. Computational lithography. Computational lithography is a critical technology in modern semiconductor manufacturing, enabling the creation of smaller, more complex chips. It uses advanced algorithms and simulations to overcome the physical limits of optical lithography, ensuring that circuit patterns are accurately printed on silicon wafers. Key techniques include resolution enhancement, optical proximity correction, and source mask optimization, which adjust photomask patterns to counteract diffraction, scattering, and resist effects. The technology relies on detailed physical models of optics, photoresist chemistry, and scanning systems, calibrated with real-world data. High-performance computing, including GPU-accelerated libraries like Litho, allows faster mask design iterations and higher yields. Recent advances combine physics-based modeling with machine learning in differentiable lithography frameworks, optimizing lithographic parameters with greater precision. By correcting process distortions and pushing resolution limits, computational lithography is essential for scaling advanced nodes, making it a cornerstone of chip miniaturization and the continued progress of semiconductor technology. Pulsar Fusion Sunbird. Pulsar Fusion has unveiled its Sunbird concept, a fusion-powered spacecraft designed to transform interplanetary travel. At its core, Sunbird uses Pulsar's dual direct fusion drive, a compact system that generates both thrust and up to 2 MW of power for spacecraft payloads. The drive offers high efficiency, with a specific impulse estimated between 10,000 to 15,000 seconds, capable of accelerating a approximately 1,000 kg craft. Sunbird is intended to operate from low Earth orbit, where other spacecraft can dock and use its fusion propulsion for interplanetary transfer, reducing launch fuel requirements. Its design supports fast cargo missions to Mars, potentially halving travel time compared to chemical rockets, and could serve as a reusable station-keeping tug or power long-distance probes. Pulsar plans ground-based static tests and in-orbit demonstrations of key components, aiming to scale Sunbird technology for global space missions, offering long-duration thrust, high efficiency, and reusable interplanetary capability. AeroVironment Skyfall. AeroVironment, in collaboration with NASA's Jet Propulsion Laboratory, unveiled Skyfall, a mission concept featuring 6 autonomous helicopters designed for Mars exploration. These rotorcraft aim to scout potential human landing sites and geological features, transmitting high-resolution images and subsurface radar data. A key innovation is the Skyfall maneuver, where helicopters are released from their entry capsule mid-descent and fly to the surface under their own power, eliminating the need for a large landing platform and reducing mission complexity. Once on Mars, each helicopter operates independently, covering wide terrain and relaying critical data on locations potentially rich in ice or water. The concept builds on the success of the Ingenuity Mars helicopter, using proven avionics, flight software, and lightweight airframe technology. By combining autonomous system expertise with deep Martian knowledge, Skyfall offers an affordable, technically mature solution to expand aerial exploration and support safe human landings on the Red Planet. TimeShift Cryopreservation Facility. TimeShift Cryopreservation Facility envisions a future where life can be paused and preserved for decades or even centuries. The facility aims to store humans, organs, pets, and endangered species using advanced cryopreservation methods that combine cryoprotectant agents, electromagnetic fields, and ultra-low temperatures around -196 degrees Celsius. AI-powered monitoring systems track conditions in real time to maintain optimal preservation, while innovative rewarming techniques are proposed to safely restore metabolic activity with minimal damage. Beyond humans, TimeShift plans to store organs for transplantation, safeguard endangered species tissue, and maintain digital memories through AI avatars. The project is led by visionaries focused on longevity, life extension, and protection against existential risks. While the concept is compelling and highlights the potential of combining cryonics with AI and bioengineering, TimeShift remains largely experimental, with scientific, technical, and ethical challenges yet to be addressed before it can become a practical, operational solution for suspended animation and long-term life preservation. Dassault VORTEX. Dassault Aviation's VORTEX is a visionary reusable spaceplane designed for both atmospheric flight and orbital maneuvering, aiming to serve military and civilian purposes. The project features a phased roadmap including a 1 and 3 scale demonstrator, an orbital smart free flyer, a full-scale cargo version, and a crewed spaceplane. Key capabilities include runway landings, a large payload bay, orbital and atmospheric maneuverability, and full reusability. VORTEX draws on Dassault's aerospace expertise from programs like X-38, Nike, and Hermes, and is supported by the French Ministry of Armed Forces. Its envisioned missions cover orbital station transport, satellite servicing and retrieval, and potential military operations from space. By leveraging European partnerships, Dassault seeks to share the financial and technical scale of the program. VORTEX represents a bridge between aviation and space, combining multi-purpose design, reusability, and national strategic objectives, positioning France as a key player in next-generation orbital operations and reusable space access. Figure 03. Figure 03 by Figure AI is a next-generation humanoid robot designed for home and commercial environments, powered by the proprietary Helix AI model that combines vision, language, and action. It is lighter than previous models and covered in soft, modular textiles for safe interaction, while its advanced perception system includes high frame rate cameras and tactile fingertip sensors capable of detecting delicate objects. Figure 03 moves at up to 1.2 meters per second, carries payloads of 20 kilograms, and operates for around 5 hours per charge using wireless inductive charging. The robot features enhanced audio, high-speed data offload, and adaptive intelligence, enabling it to plan and learn in real-world spaces. Designed for scalable production, Figure 03 aims to perform household chores, navigate cluttered environments, and support light commercial tasks, making humanoid robots more practical and accessible for everyday use. Its combination of safety, dexterity, and AI intelligence positions it as a significant step toward widespread human-robot interaction. Plenty Future of Farming. Plenty is a vertical farming company transforming how food is grown by using indoor 3D towers instead of traditional flat trays. Its farms combine AI, robotics, proprietary lighting, and fully controlled environments to maximize yield while minimizing resource use. By using less water and land than conventional farming and growing zero pesticide produce, Plenty demonstrates a sustainable approach to agriculture. Its Compton, California farm produces millions of pounds of leafy greens annually for major retailers, and new facilities like a vertical strawberry campus in Virginia aim to enable year-round production. The company collects millions of data points daily to refine growing conditions, supported by a large R&D center in Wyoming. Challenges remain, including high energy costs, capital intensity, and scaling efficiently. Despite these hurdles, Plenty's vision of localized, sustainable, and resource-efficient farming offers a glimpse of the future of urban agriculture, reshaping food production for climate resilience and food security. Extropic thermodynamic computing. Extropic is developing a new type of computer that uses thermodynamic principles instead of conventional digital logic. Its core hardware, the thermodynamic sampling unit, employs probabilistic bits that fluctuate between 0 and 1 using controlled thermal noise. This allows the system to efficiently sample complex probability distributions without the massive matrix calculations typical for GPUs. Extropic also created the denoising thermodynamic model, a generative AI framework optimized for this hardware, which gradually transforms noisy inputs into structured outputs while being highly energy efficient. Early development platforms like XTR0 and the open-source Python library TarML enable experimentation and simulation of TSUs. The approach promises massive energy savings, new ways to handle probabilistic inference, and applications in generative AI, Bayesian reasoning, and Monte Carlo simulations. Challenges remain with analog noise, error mitigation, scaling, and integration with existing AI workflows, but the technology represents a bold new paradigm in energy-efficient AI computing. Honda EV Outlier. Honda's EV Outlier concept, revealed at the 2025 Japan Mobility Show, is a futuristic electric motorcycle that redefines conventional bike design. Featuring in-wheel motors on both front and rear wheels, it eliminates the traditional drivetrain while enabling advanced torque distribution for enhanced handling. Its open, modular frame allows flexible battery placement and centralizes mass, paired with a double wishbone front suspension and low-mounted rear monoshock for dynamic posture and stability. A continuous LED strip and sleek bodywork emphasize its electric-focused aesthetics, while camera-based mirrors and a wide instrument cluster improve rider awareness. The design philosophy prioritizes gliding, ecstasy, and low-riding experiences, offering adjustable torque and a deeply connected ride feel. Honda envisions this concept as a glimpse into post-2030 EV motorcycles, combining innovation, sustainability, and riding excitement. The EV Outlier merges radical styling, technical sophistication, and forward-thinking design, signaling Honda's vision for the next generation of two-wheeled electric mobility.